Well, welcome to second part. So if you didn't watch the first part before, otherwise you will not understand anything here. So in this tutorial, in this video content, you will understand how you can build, how you can cross-compile the modules. So what we are going to do in this video content, we will install, I explained this link before, right? So we will install the Qt declarative module, which is here. So this is as known as, the QML. Then after this installation, after this configuration and compilation, we can compile our QML applications, or we can run the QML applications. With this, that I will explain, with this, I would like to also to install Qt shader tools. Shader tools here. This is, you don't have to do this, but I would like to do this because we will need in the next, okay? Just try to follow my steps, then you will understand. So first, just go to the home directory that I am, here. Home ulash, I'm in my user. So now we install the tar files here. All the steps, all the explanations are available in the link. So I just paste here. Oops, I couldn't paste it. So these are not really, big modules like a base. So that is why, yes, you can install it quickly. As you remember in the first tutorial, we first built for the host, right? We built the Qt for the host. That is the way for the Qt6, not like the Qt5. So for the modules, the rules are same. First, we will build this for the host. Then we will build this to compile and configure this for the Raspberry Pi. So then we should go to the Qt6 host, as I remember from the first tutorial that here this is the binary directory. This is not what I'm looking for. Qt host build, yes, I remember it. Qt6 host build. So okay, Qt base everywhere source directory is here. We'll just enter Qt shader tool and the same thing for the declarative. This will take some time, yes, quick, fast. As you see that here now, we have two directory more, Qt declarative everywhere and Qt shader tools. So if you go to the Qt declarative directory, you will see there are a lot of course, the files that you can check. I don't know. There's a dependencies YAML, right? So just check the content of this dependencies YAML. See, there's a definition for dependencies. It says Qt base. This is the reference commit number, I think. So required true. That means we need Qt base that we built in the first tutorial. So this is Qt image format. This not all is required here, but it depends on you also. So Qt image format is not required. Qt language server, SVG, and shader tools is not required. But I like to install this now. We will need it in the next, not in this tutorial, but in the next. So first, there is a dependency, the order. So the first, then I will build first, not the declarative to shader. So what I'm going to do, I will enter the shader tools everywhere directory. So we are in the host build, is correct, Qt6 host build directory. That means we will build this for the host. And then we will go to the directory where the binaries exist for the host. Okay, the binaries that we compiled for the Qt, for the host. So Qt6 host bin here. And as you see in the directory, in bin directory, there is a Qt6Make that we used right before to test our host compilation with a simple hello world application. So there is also Qt configure module. We will follow the same step for the also cross compilation. It will be exactly the same. So we don't need to provide the toolchain also, because we provide for the Qt base, right? It's the system knows right now. The system knows that where is sysroot, what we need, what is our configuration. It knows everything. We don't need to, again, we don't need to represent these things again and again. So here then Qt configure module, and that is it, I think. Then we will just give the point for the path. Let me try. Yes, looks okay. Okay, configuration done, generating done. Then we will compile it, right? Cmake build, not this one, Cmake build parallel 4. So it's quite fast. This is all the shader tools. So this one is finished. Then the building is finished. So then Cmake install. I made a mistake here, this one. Then these are installed under the Qt6 directory that we used the scripts, right? Now we will build the declarative. Just go to the Qt declarative directory. We will follow the same steps exactly using this Qt configure module dot, like this. Then this will configure our declarative. The point also that you can check after the declarative configuration, yeah, this configured done, if it's for host. So there is still, config summary. So every module has a summary kind of. So you can check it if you want, what you are doing, if you want to know more. So it's all yes. That means, yeah, you have a network support, QML, XML, HTTP, I don't know. So flippable items, flippable module you have now in the Qt quick. So other things, so you can check here. This should all yes. This is for, of course, host. And Cmake build parallel 4. Of course, this will take much more time than the Qt shader. After this, we will follow the same steps for the Qt, for the Raspberry Pi, for cross compilation in the Qt cross directory. After this, we should install it like before. Cmake install. So all the related, QML related binaries will be installed for the host in this directory that we used before. Now the host part is okay. Go to your home directory, not here, home directory, and we have Qt cross directory here. We will do the all configuration and the build process in this directory for the cross development. Enter this directory, and we will make the same steps, right? Just enter the files, Qt, first one shader tools, and Qt declarative. Enter to shader tools everywhere. So first, like in the host, first we should build this module because there's a dependency. And like here, that you can check the same directory. So home, my username RPI, nope, not this one, Qt6 RPI. Bin here there is a Qt configure configure module. So dot means the path. That means you can run this script from another path. I'm giving now this path, this directory. You should build this directory. That means the dot means this. So let's start it. Let's see what will happen. As you see that the compiler is found, I didn't see configuring is done, generating done. So it found already a compiler. Skipped. So I didn't give any tool chain, right? And as you remember, this is difference. As you remember, in the Qt base module, the main module, we should provide for the configuration toolchain Cmake, right? To toolchain path, sysroot path, other things. So here I don't need to do that. Why? Because we did already for the Qt base, right? You don't need it anymore. Then we should simply build here parallel 4. This is of course will be quite fast. You can see some kind of warnings. As long as there's no problem, there is no real errors, so don't worry. Building process finished. Now we can install it. Cmake, let me clear the screen that you can see better. Cmake install install the in this the directory, the binaries to our Qt6 RPI. So these are installed Qt6 RPI directory. As you see, we have now related header files, Cmake, and other things. Then, like in the host, go to qtdeclarative directory. We are in the Qt cross directory. This is for the cross development. And now you can check again, we checked before. So what we will do to call the Qt configure module script. So I'm calling it here again. This will prepare everything. As you see that it found OpenGL, for example, according to our configuration for the base, right? We enabled the OpenGL, and if you check the first video, the first part, we enabled the OpenGL desktop. So we need OpenGL. And it found it here. Otherwise, if it cannot find OpenGL, then the configuration will fail here. Now it's working. Configuring done, generating done. Then Cmake build dot parallel 4 core or whatever, how many core you have, you can put there. Then this will take some time, probably. So after some time, the linking is finished, building is finished. So there are some bunch of warnings, there are a lot. So don't worry about them right now. If you use different toolchain, these output can be different. Well, now what we did, we built the Qt declarative now, so we can install it. That means the binaries, the build binaries will be sent to the Qt6 RPI, right? We did before. So now we can test the QML binaries. for cross compilation. So for this, let's go to the home directory and let's create another directory for the example, cross example QML. Enter this directory. We'll create 3 different files first. Cmake lists, txt, main cpp, and main QML. So let's open these. I will provide all the content. You can find this in the link below the video. I will copy everything. Then I will explain what I did. So this is for the Cmake. So as you see, this is the same with the previous example mostly. So there is one more difference, here. This is the Qt6 Quick. So I simply bind, the libraries Qt6 Quick. So this is the way when you compile a new module, so you can bind like this with the Cmake. So we need a main cpp here. So be careful about this path. Update this path according to your username. So this will the main QML. This one. This is a simple QML application. There is a button here, and this button. Where is the button? Yeah, the button here. When you click the button, and yes, it says text is changing, so it's clicked. The text will be, clicked. I think these are okay now. So let's compile and let's see what will happen. I'll go to directory. I'm not going somewhere. I'm now in the Qt cross example QML, and I will call the script qtcmake script, qt6 rpi qtcmake. Because in the bin directory qt. So okay, configuring is done, generating is done. Then we can build it. It's built. But I forgot something. Yes, I forgot something. Okay, we have binary now. We should send this to Raspberry Pi with the main QML, but we forget to send the binaries to the Raspberry Pi. So first, let's go back. I forget it. So there is where was this? I think, yeah, it doesn't matter. We should sync the directories with the Raspberry Pi, right? So let's just simply run this command that we ran before. So we are simply sent everything in the qt6 rpi directory to Raspberry Pi under local. We did this before, but we have now new binaries, right? Otherwise, our application cannot find the dependencies. So let's try. I think password is okay again. So now, as you see that the QML files, the binaries are sent to the Raspberry Pi. After synchronization, then we can send our application. So simply qt cross example QML. So CSP secure copy hello qt6 QML, the name of the application, and we need to send the main QML. They should stay, main QML should stay in the home username and there exactly. So here. So they are sent. Let's switch to Raspberry Pi. Okay. hello Qt6 QML application is here. This one, and the main QML is here. Then we need to export. I opened the terminal. I just restart the Raspberry Pi, so I have to export the libraries again. USR local and Qt6 RPI, then it should be lib. Let me check. USR local LD library paths, correct, I think. So now we can check the dependencies, for example with the LD Qt6 QML. So as it is seen here, lib OpenGL SO lib6 GUI lib Qt6 QML. So these are found. That's okay, there is no problem. So let's try to run Qt QML. Yep, it's working. QML application is working now. So all the cross compilation for the Qt declarative is successful. So let's click the button just for an example. Yep, it's clicked. I think I cannot read the text here correctly, but I think it's working. So let's try again. Button clicked and it's clicked. So that is it for this tutorial. So in the next one, probably we will maybe talk about more about these modules, or I want to talk maybe, I don't know, about interactive development environments, or more about the Cmake modules, Cmake commands. So let's see what will happen.